The question says, out of the following, which has highest dipole moment? Okay, which has highest dipole moment? You can see organic compounds are given here. We can draw the structure. Okay, let's draw it, and then we find out the dipole moment. 2,2-dimethyl and propane, 3 carbons are there, 1, 2, and it is 3 is there. Okay, 2,2-dimethyl, 1 methyl group here, 1 methyl group here. Okay, now in this case, if you look at this carbon, okay, so by finding the geometry also we can determine dipole moment. And always keep in mind, if the central element in a molecule is having a regular geometry, which is described by hybridization. Okay, I'm not talking about Westward theory. I'm talking about the geometry, regular geometry, which is determined by only hybridization. In that case, dipole moment will always be 0, and if dipole moment is 0, then it will be non-polar by nature. For example, if you look at here, this carbon is forming how many bond? 4 sigma bond. It is forming 4 sigma bond. Okay. In this case, hybridization we what? sp3, and then we are getting regular geometry, that is tetrahedral. Okay, regular geometry is tetrahedral. In this case, dipole moment will be 0. If regular geometry is there, central element does not carry any lone pairs, and it is having regular geometry, dipole moment will be definitely 0. Okay, the substituent atom should be same. Here condition is there, because we cannot say, like, if the substituent atoms, some substituent atoms are different, then in that case dipole moment will not be 0. Okay, such as if I take, this is what CH2, this is Cl2 is there. So you can see substituent atoms, 2 hydrogen are there, 2 Cl are there. In this case, dipole moment will not be 0. If I take CH4, all the substituent groups, atoms are same. In this case, definitely dipole moment will be 0. But in this case also, you can see all these groups are same only. Dipole moment will be 0. Okay. Even if you write CH3, it is forming how many sigma bond? Here we have 4 sigma bond. It will also lead to tetrahedral geometry. Okay. So in this case, there is no polarity. Okay, little bit polarity you can say, because carbon is there. Carbon, there is no electronegativity difference. But if we talk about carbon and hydrogen, some electronegativity difference will be there. So little bit polarity you can think. Okay, little bit polarity. But if you talk about this element, in this case 100% dipole moment is 0. Now we move on to the next compound. Trans 2 pentene is there. Pentene, 2 pentene, C and C, and we have it is C and C. Okay, pentene, 5 carbon are there. 2 pentene. So let's say I attach the double bond to the second carbon. Okay. Now transposition is there. So I do one thing. I attach 2 carbon this side. This is what C, and it is C. I attach this carbon opposite side. This is C is there, and this is H is there, and this is H is there. This is the transposition. These alkyl groups are in opposite. Okay. Transposition is there. Okay. In journal organic chemistry, we have learned alkyl groups are electron donating group. They can donate electron density, acting as a positive inductive group. Okay, positive electron donating group. This is also alkyl group. This is also alkyl group. It is what? Ethyl group, and in this case it is what? Methyl group. So you can see donating electron density. In this case also donating electron density. Keep in mind, in this case dipole moment will be 0. No, sorry, let me correct. Dipole moment will not be 0, because these groups are different. These groups, in this case dipole moment will be smaller. In this case dipole moment will be larger, because more donating of electron density is there. Okay. Now let's see, if I write the condition, it is C double bond C, and in this case if I mention CH3, and it is what? CH3, and it is H, and it is H is there. In this case you can see this dipole moment will be same, because these two groups are same only. This length of this dipole moment, the length of this dipole moment will be same, and in this case dipole moment, overall dipole moment will be 0. But in this case it will not be 0, because these two groups are different. In this case dipole moment length will be shorter, in this case will be longer. Okay, so some polarity will be there. 100% it is not, we cannot say dipole moment mu is equal to 0. It is not non-polar by nature. Some polarity is there. Very interesting compound. Okay. But now let's say if I say cis-3 hexene is there. Cis-3 hexene. So this is the first compound, this is the second compound, then we have third compound is there, third compound. So hexene, how many carbon are there? 6. 1, 2, 3, 4 and 5, and it is 6 is there. Okay, 3 in the third carbon, let's say attach, here we have double bond. Okay, now if we write in a cis form, so in this case we can write, let's say it is C double bond C, and it is C C. Okay, and in this case also it will be C, and it is C is there, and it is H, and this is H is there. 10. Okay, this is the form. In this case you can see electron donating group. In this case also you can see electron donating group. They are not coming opposite to each other. If they are coming opposite to each other, dipole moment will be 0. But in this case you should be careful. If this is what we have, and in this case this arrow mark is there, in this case dipole moment length is small, in this case dipole moment is very large. In this case we cannot say 100% cancellation of the dipole moment will be there. Some polarity will be there, because this arrow cannot cancel this long arrow completely. Still some part will be there. One way we can say neutralization, they will be neutralizing each other, they will be cancelling out each other force. Okay, but it cannot cancel out this long dipole moment. Okay, so in this case these arrows are coming like this, these arrows are coming like this, so dipole moment will be there. Okay, dipole moment. Even if you say, sir, this hydrogen is there, carbon is more electronegative, carbon is more electronegative than hydrogen, this dipole moment will be coming. This dipole moment, this arrow mark is coming from this side, this arrow mark is coming this side, they will be coming opposite to each other, they can cancel out. But here the electronegativity between carbon and hydrogen, and here electronegativity condition is different, because this group, large group is there, two carbon are there, 2 carbon present in the alkyl group, they are donating electron density. And in this case you can see, with the electron activity between the atoms is different, then dipole moment will not cancel out 100%. So you cannot say this arrow mark will 100% cancel out this arrow mark. No, it is not possible. But if I mention this is C double bond C, and it is H is there, then if I mention H and this arrow mark is coming, this arrow mark is coming, let's say something we mention here, it is C2H5 is there, C2H5 is there, C2H5 is there. In this case you can see it can cancel out these two arrow mark coming opposite to each other, they will cancel out each other. So dipole moment will be 0 in this case. In this case also we can mention this arrow mark and this arrow mark is coming, they will cancel out each other, and these two arrow mark will also cancel out each other. If arrow mark are going here, when they are coming closer together and their length is same, will cancel out, dipole moment will be 0. But if we mention arrow mark like this also, dipole moment will also be 0. Okay, so in case of cis 3 hexene, dipole moment will not be 0. You can see they are coming and adding up, so dipole moment will not be 0, it will be highly polar by nature. Even if you talk about 2,2,3,3 tetramethyl butane is there. Butane means how many carbon are there? 1, 2, and it is 3, and it is 4 is there. Okay, 2 tetramethyl C and C is there. Here also 3 and C is there. Okay, in this case same situation. 4 sigma bond, sp3 hybridization, then tetrahedral geometry, regular geometry there, dipole moment will be 0. Dipole moment will be 0. For this carbon also same, 4 sigma bond, sp3 hybridization, tetrahedral, dipole moment will be 0. So highly polar, we have option C is correct. Option C. Okay, very interesting question. Especially trans 2-pentene. You can learn something from this compound. If you like this video, please share and subscribe to the channel.